What if gig worker acceptance isn't governed by a single reservation wage, but by a history-dependent threshold system? Researchers are applying the Preisach hysteresis operator, originally developed for ferromagnetic materials, to labor markets. In this framework, each worker carries a pair of latent thresholds, an acceptance ceiling and a rejection floor. Between them sits an indifference zone, where current decisions inherit directly from past ones. This structure naturally produces hysteresis. A wage drop suppresses acceptance more than an equivalent rise restores it, because workers only reactivate when prices cross back above their original ceiling. The observational problem is stark. You only see binary outcomes, accept or reject. Directly recovering the full two-dimensional threshold density from scalar data is mathematically ill-posed. So the authors bypass it with a dual-output neural network. It uses a shared encoder to project transaction features into a common latent space, then splits into two heads, one predicting mean utility for accepted tasks, the other for rejected tasks. Crucially, they train it with a margin loss that enforces U1 greater than or equal to U0 for all accepted instances. The difference, U1 minus U0, becomes the Preisach gap, a clean, non-parametric proxy for the population's net acceptance disposition. That gap feeds into an XGBoost classifier, alongside clip-stabilized price-to-threshold ratios. This encoding step is where the model actually learns. Workers don't evaluate wages absolutely. They compare offers relative to their estimated utility centroids. Relative encoding alone pushes AUC up by 11 percentage points. On nearly 37,000 transactions, the pipeline achieves an AUC of 0.799 and a Jaccard of 0.827. More strikingly, it quantifies a structural paradox. By simultaneously cutting wages on high-probability tasks and raising them on low-probability ones, the model projects a 21% reduction in the total wage bill while increasing fill rates by nearly 10 percentage points. The takeaway is clear. Labor supply isn't static. It's hysteretic. And by modeling utility as a Preisach operator, we finally get a rigorous, differentiable way to capture reference-dependent decision-making at scale. The full architecture, ablation studies, and identification strategy are linked below.